This is 8.3, the quadratic functions in standard form. And what we're going to do is we're going to look at a couple equations and learn how to graph it in standard form. But let's talk about what standard form is. Well, last section we talked about vertex form. Vertex form looks like this. Y equals parentheses x minus 3, and then all of that is squared plus 5. And if you remember the vertex, the vertex is, it looks like the opposite of that, so that's 3 and then 5. So that's the vertex of that parabola. Now, how do I change that to standard form? Well, standard form is going to end up looking like y equals ax squared plus bx plus c. And so what we want to do is basically we're going to take this right here and we're going to square it. So x minus 3 squared. And remember I showed you guys a quick way to do it, or if you want to write it out twice, x minus 3 times x minus 3, and then just FOIL it, you can. But this is going to end up doing x squared minus 6x plus 9, and then you still have the plus 5 out there. And then I'm just going to combine like terms. So notice the A is 1, the B is negative 6, and the C is 14. All right, so, and again, it's good to recognize the A, B, and C for several reasons as we come along. Now, standard form is very common. Matter of fact, it's more common than the vertex form that we learned already. So this is the equation of a quadratic equation that will graph a parabola. And this number out here, the C, is actually going to mean something to you. This is actually going to be the y-intercept. So that's one cool thing about putting it in standard form. We know the y-intercept right off the bat. And again, one way to, how do you know that? Well, if I remember to find the y-intercept, you put 0 in for x. And if I put 0 in for x, I'm going to get 14. So that's how come I know that's the y-intercept. So that's a good way to find the y-intercept right off the bat. So right now I know the vertex because it was in vertex form, and now I know the y-intercept, and that's enough to graph a parabola without your calculator, which is good. And one way to check this, by the way, just to see if you did your math right, you could simply use your calculator and plug in both the vertex form and green and the standard form, and plug them in and see if they're both the same equation. So in other words, if you look at my calculator, I plugged in both of those equations, and when I push graph, if I did the math right, they should literally be the exact same equation. And they are. So literally, if you graph them, you'll see that the blue one graphs first, the blue one meaning the one I typed in first, and then the red one. And the red one is on top of the blue one. So they're literally the same exact parabola. So that's one way to check to see if you did your math correct, changing it from this form to that form. All right, so let's actually graph one of these. Now, one of the things I want you to notice with standard form, if we go back to this equation, one of the things that you want to try to find is the axis of symmetry. So the axis of symmetry, if you remember, is the middle of the parabola. And one way you can do this is there's a formula, x equals negative b over 2a. And so this right here is crucial in finding the axis of symmetry. So again, we found our ABC right over here. So follow the formula. So negative b, so negative 6, which is going to make that a positive 6, and then 2 times the a. So that's going to give me 6 over 2, which is 3. So the axis of symmetry on this equation is 3. So which is a good. Once you graph the parabola, it will be the middle of the parabola. So let's apply that here. So again, we have our A, which is 2. This is my A, that's my B, that's my C. So A is 2, my B is 4, and my C is 3. And to find the axis of symmetry is negative B over 2A. So negative B would be negative 4 over 2 times A. negative 4 over 4, which is negative 1. Now remember, what that gives me is the axis of symmetry. So go to negative 1, and I automatically know this is the center of the parabola. Again, you can do this without your calculator. That's the center of my parabola. Now the way to find the rest of the points, remember what this point is? That's my y-intercept. So that's going to come in very handy when I start making my XY chart. So I automatically know 0, 3, this is my y-intercept. I automatically know that. So I'm going to put 0, 3 right there. Now also, if you notice A is positive, which means this parabola opens up. So this is going to be a parabola that opens up. Now how to find the vertex? I keep saying over and over, the vertex is the crucial point. Well, if I know the axis of symmetry, remember the axis of symmetry goes through the middle of the parabola? That means it hits the vertex. So all we have to do is substitute. We know x is negative 1, so we're just going to substitute negative 1 in. Again, that's my axis of symmetry. If we substitute negative 1 in, then the vertex will actually show up there. So if we take 2x squared, so 2, and we're going to plug in negative 1. Notice I substituted the x's for negative 1. So that's going to give me 2, negative 4, plus 3. And that's going to end up giving me 1. So negative 1, 1 is my vertex. And I know this parabola opens up. And so now all we have to do, remember it's reflective, so if we know this space, then we also know that space, that dot. So because it's going to be reflective. And let's just plug in one more number. Let's plug in positive 1. If we plug in positive 1, so 1 squared times 2 plus 4 times 1 plus 3. So that's going to give me 2 plus 4 plus 3. That's going to give me 1, 9. So if I go to 1, 9, and remember it's reflective, so I'm going to reflect it on the other side, and now I have enough to graph my parabola. So I graphed my first parabola. So notice there's a couple things. Remember, this is your y-intercept. Are there any zeros? No, there's not. Remember, zeros are where it hits the x line. They're also called roots. They're also called x-intercepts. There are no zeros. So no zeros on this parabola. Okay, no x-intercepts. The axis of symmetry, we already talked about it. We found that. So we're going to label it AOS. And then we have, and then let's talk about the interval notation. Notice it's decreasing. Remember, you read the parabola from left to right. That's how you read all the functions, from left to right. So it's decreasing from here to here. So let's say decreasing. It's decreasing from negative infinity all the way until you get, it keeps decreasing all the way until you get to the vertex at x equals negative 1. And it's also increasing. It changes directions at the vertex. All the way to infinity, positive infinity. All right, so let's go ahead and graph. And by the way, you can always verify that if you want to go to the calculator and verify the functions of 2x squared plus 4x plus 3, and then push graph. And you can verify the parabola, go to the table, and verify the table values as well. All right, so let's look at this function right here. So again, we have a function f of x equals negative x squared minus 2x plus 8. So one of the things, and that's in standard form, so you can see the a is negative 1, you can see the b is negative 2, and you can see the c is positive 8. I also noticed the a is negative 1, which means this opens down. This parabola opens down because of the negative a. So the very first thing you want to do is find the axis of symmetry. So x equals negative b over 2a. So negative b over 2 times a. So that's positive 2 over negative 2, which is negative 1 again. So we have another axis of symmetry. at -1. And the very first point I would substitute is -1. Remember, if you substitute whatever the axis of symmetry in, you substitute that in, then this will be the vertex. That's how you find the vertex, because the vertex has to be on that, the axis of symmetry. The axis of symmetry, remember, is the middle of the parabola. So the vertex is right there. So we're going to substitute -1 in. So -1 squared minus 2 times -1. So that's going to give me -1 plus 2 plus 8. And so that's going to give me 10. So -1, 10. And that's my vertex. Now, what we want to do also, if you notice the positive 8, that is my y-intercept. So I know 0, 8. Right off the bat, I know that's 0, 8. And I'm going to reflect it over, automatically reflect it over. Now, one of the good things to do is to always find the zeros. So if I want to find the zeros, I want to plug in another number, like 2 or 3 or 4, and I want to find where they cross at. So I'm going to go to my calculator, -x squared minus 2x plus 8. If I look at the graph, notice it looks like 2, 0, and -4, 0. So -2, or it's +2, 0, and -4, 0. So now I have enough to graph my parabola. And so this is my vertex. That's my vertex. We have our axis of symmetry. We said it goes down. So let's talk about increasing and decreasing. So notice this parabola, because it goes down, we always read the problem from left to right. So notice it's increasing first. So increasing, the interval notation would be from -infinity all the way to, you get to the vertex, which is at -1. And then decreasing, would start at -1, and then would go all the way to positive infinity. And that's how you graph a parabola in standard form.